All right, this is the second lesson of trigonometry. And it really is just a continuation. We're building on what we did in 7.4. You really have to have a good handle on 7.4, and then from there, it's quite straightforward. So I'm just going to do a nice quick little review. Okay, here I have a right triangle. And as I said earlier, prior to grade 10, the only thing that you could do with a right triangle is solve for a missing side given two other side lengths. So for example, if I was told that this was 34 and that this here was 27, okay, I could solve for the length of RS by squaring the hypotenuse, subtracting the square of the other side, and then square rooting my answer, right? Okay, so that's a review of elementary school. I'm not going to spend a ton of time there. Something that we talked about in the previous lesson was another way of labeling the side lengths. So instead of calling this RS, because it is across from big angle T, I can call it little side T. Instead of calling this big S, or pardon me, instead of calling this RT, I can call it little s because it's across from the 90-degree angle from big S, and then I can also label that as little r. So that's just another way of labeling triangles. This is going to come into effect as we progress through the unit. Okay, now 7.4 is all about the primary trigonometric ratios. And in order to write out the primary trigonometric ratios, we need a reference angle, okay? We never make the 90-degree angle our reference angle, okay? We do not do that. So you can pick one of the other two. In this case, I'm going to start by making this my theta, or my reference angle, okay? Once I've established what the reference angle is, I can label accordingly. And again, I like to label in the order OHA. So if I go across to the opposite side of the angle, this guy becomes my opposite side length. This guy is always going to be the hypotenuse because he's the longest side of the right angle triangle and he's across from the 90-degree angle. And then by default, this last guy is the adjacent side. Okay, adjacent just means beside. It is beside the reference angle. Again, a lot of times kids will say, well, so is this. That one's beside the angle. Yes, but we've already called that the hypotenuse. It already has a name. Okay, and then once we write out the labels, the OHA, opposite, adjacent, hypotenuse, we can write out the primary trigonometric ratios. I'm actually going to go ahead and follow that exact same process again, but this time, in a different color, I'm going to choose a different reference angle. So if I had chosen to make, we'll give it a different name. We'll call this guy beta, okay? Just a Greek letter. If I had chosen to make T my reference angle, well, now this guy would be my opposite because this guy is across from that angle. This is still my hypotenuse. The hypotenuse never changes. And that's why we never make this the reference angle. And then by default, this last guy would be my adjacent. So this labeling process is very important in solving these questions correctly. And if you have more questions about this, please message me on Edsby. Okay, so we're going to go ahead and dive into the first example from the note. In the first example from the note, we're given a right angle triangle, okay? Again, notice that prior to this lesson in 7.4, if you were given this in grade 9 or in elementary school, you'd be stuck, okay? The Pythagorean theorem only works when we're given two side lengths of a right angle triangle. In this case, we only have one. And we didn't really talk about working with angles and using angles to determine side lengths prior to trigonometry in grade 10. So this is kind of new territory. So here it says, state two trigonometric ratios that you could use to determine little a. So before I go on, let's go ahead and label this guy. This is little a because it's across from big A. Little b is already labeled. That's going to make this guy little c, okay? I think I mentioned this in the previous lesson. Whenever I'm doing trig questions, I always like to have my handy dandy acronym, SOHCAHTOA, written somewhere on the page so that I can refer to it as I'm going through. Okay, so in order to determine the value of little a, okay, I'm going to go through that process of labeling my triangle and with my OHA, and then looking at what I have and what I need, okay? So if I want to label this using OHA, This is the reference angle I'm going to use. The reason I'm using 40 is because I've already gone through this. We cannot use the 90-degree angle. That's a no-go. And yes, I could easily solve for big B, but why? They gave me 40, work with 40. It makes my life easier. And just in case I had a lapse and I calculated this incorrectly, I'm better off to use an angle that was given. So if this is the given angle, that makes, this my opposite. Again, the process of labeling is so important. Of course, this is going to be my hypotenuse because it's across from the 90-degree angle. And then this guy left over is my adjacent. He is beside the reference angle. Okay, let's say I wanted to solve for little a. Then I have to establish what do I have and what do I need. Well, I need little a, and according to my labels, little a is the opposite side. I have b equal to 6. That is my adjacent side. So now I look at my SOHCAHTOA, my primary trigonometric ratios, and I have to decide which one am I going to use if I need opposite and I have adjacent. Well, sine doesn't have opposite and adjacent in it. Cosine doesn't have opposite and adjacent in it, but tangent does. So the tangent of 40 degrees, remember, I can never see sine, cos, or tan without an angle after it. So the tangent of 40 degrees is equal to the opposite, which in this case is little a, over the adjacent, which in this case is 6. So part A, they don't want you to actually solve for little a. They want you to write out the primary trigonometric ratio that could be used to do that. And I've accomplished that goal. Okay? Now, part B is the same, or pardon me, we're still on part A. They wanted us to come up with 2 primary trigonometric ratios. Okay? So I'm just going to really quickly reproduce my diagram. This is C, this is B, this is A, this was 40, this was little a, and this was 6. Okay, but this time, in order to come up with a second primary trigonometric ratio, I'm actually going to use this as my reference angle, okay? So we know, because all interior angles of a triangle add to 180, okay, this guy must be 50. If I decide to make this my reference angle, that means this is going to be the opposite. This is going to be the hypotenuse. Of course it is. The hypotenuse doesn't move. It's always across from the 90-degree angle. And this is going to be my adjacent. Okay? This is the first time I'm making a video in broad daylight, so you will hear my children playing/screaming in the background. Okay. So now I have to go through that same process. I have to establish what is it that I have and what is it that I need. Well, in this case, I have the opposite side. It's labeled in my diagram. This time I need the adjacent because my goal was to write a trig ratio that could be used to solve for little a. So now I go through, and I erased it, but I'll rewrite it here. I go through my acronym SOHCAHTOA, used to remember the primary trigonometric ratios. And again, I'm going to choose tangent, okay? Because tangent is the only ratio that has opposite and adjacent in it. So the tangent, this time of 50, because I used a different reference angle, is equal to the opposite side, which is 6, over the adjacent side, which is little a. So this is a nice example to show you, okay, that we can use 2 primary trigonometric ratios to solve for the same unknown. And you'll notice they definitely have some similarities and they definitely have some differences, okay? And you'll kind of come to some cool observations as you work through the homework. Now, okay, so these were the 2 primary trigonometric ratios, 2 different ones that we came up with that could be used to determine little a. Now we're going to actually go ahead and solve for little a, and I'm going to do it using both so that you can see how we would go about finding the final answer here. So here, once I get to this point, it's easy peasy. I can just cross multiply. Let's make that look like a fraction. This is what I need. A times 1 is a. And here, I'm just going to multiply those guys together. I have to multiply the tangent of 40 degrees by 6, okay? And again, I don't calculate tangent 40 and put it down. I like to do all my calculating at the end because I don't want to have to round midway and compromise the accuracy of my answer. Here, my final answer ends up being 5.03 when I round to the nearest hundredth, okay? Now, if I was doing this on a test or quiz, I could stop right there. But because this is the lesson and I want to address commonly made mistakes, I'm going to show you how to get the solution from here as well. Over here, if I cross multiply, again, I'm interested in solving for a, so I have to cross multiply with that first. A times the tangent of 50 looks like this. A times tangent 50 degrees equals 6 times 1, which is 6. My goal is to isolate A. A is being multiplied by the tangent of 50, so I have to divide both sides by the tangent of 50. When I do that, these guys cancel each other out, which is exactly what I wanted. And now, make sure your calculator is in degree mode. I should have said that right at the beginning of the lesson. In one full swoop, I can enter 6 divided by tan 50 on my calculator and get the final answer. Okay, so like I said, we're going to go 6 divided by the tangent of 50. And I get the exact same answer, 5.03, okay? As I mentioned in the previous video, you need to be trying these calculations as I go through the lesson because everyone's calculator is a little bit different. And you don't want to find out on our first quiz or on our unit test that you've been calculating these incorrectly. Okay, the next example from the note, we're given a right angle triangle with 2 side lengths. And again, prior to grade 10, the only thing that you'd be able to do here is calculate that missing side length using the Pythagorean theorem. However, if you read the instructions for example 2, it says solve for the unknown angles. So I know that this is 90, but I do not know the value of big C. I don't know that angle, and I don't know this angle. And this is where Pythagorean theorem falls short, and this is where we're going to utilize the primary trigonometric ratios. And that is my handy dandy acronym that I like to have written at the top of every page, every homework, every daily drill, every quiz, test, so that I can refer back to it as needed. So I've been asked to solve for the angles. I'm going to do so using the primary trigonometric ratios. It certainly doesn't matter which one you do first. In the teacher copy of the note, I did B first. So just to mix things up, I'm actually going to find C first, okay? So I am solving for big angle C, which means that's going to be my reference angle, and that is going to dictate how I label my diagram. So if I am solving for big angle C, that means across from it is where I find my opposite. Remember, you want to label your OHA. This guy, of course, is going to be the hypotenuse. That's not going to change. Whether I had made this or that the reference angle, the hypotenuse is always across from the 90-degree angle, is always the longest side. And then last but not least, by default, this guy is my adjacent, okay? So now, once we label our OHA, we have to decide, what do we have? What do we need? Well, I have the adjacent and the opposite. So I have the opposite and the adjacent. Here, I need an angle, okay? So let's go over here and decide which primary trigonometric ratio has opposite and adjacent in it. And by pure coincidence, it's tangent, okay? So the tangent of, and this is where this example is different than the ones we've done previously. We don't know the angle. The angle is the unknown. So we're going to say the tangent of big C, because we don't know what it is equal to the opposite, which is 12, over the adjacent, which is 8. Okay? Now, there's no such thing as dividing by the tangent on both sides. The opposite or the inverse operation to tan is exactly that. It's called the tan inverse, and we talked about this calculator button in the last lesson. So, I am going to put 12 over 8 on my calculator, and then I'm going to hit Shift Tan because that's the tan inverse button. I don't know if you can see it. Okay, and I get 56.31 degrees. Okay, Like I said, the textbook rounds everything to the nearest degree. Just to improve our accuracy, I want everything in this unit rounded to 2 decimal places. Okay? Now, I've seen students run out of time on assessments because they find the hypotenuse. That is a waste of time. We don't need the hypotenuse. We used what we were given. We had opposite and adjacent, and then we picked the appropriate primary trigonometric ratios. Now, you can use the primary trigonometric ratios to solve for B, but a far more efficient way to now solve for that other missing angle is to just subtract the given right angle and the angle we just found from 180, because we know that all interior angles add to 180. And here, B is equal to, 33.69 degrees. This is going to cost you a half mark, folks. Don't forget, if you're giving me an angle measure, it has to include degrees. Okay, question number 3 in the note. We have to make sure that we read this question carefully to produce the diagram correctly. So it gives us triangle ABC. Okay, I'm going to start with a right triangle because anything in chapter 7 is a right triangle. Okay, and then you don't want to just label ABC wherever, because in this question it says angle C is where the 90 degree is. So this has to go there. Okay, now at this point it really doesn't matter where I put A and B, but you just have to be really careful about that. Okay, then it also says that little c is 11.3. Little c has to be across from big C. And it says that little b, which has to be across from big B, is 9.2 centimeters. Okay, then it says calculate angle B, which means angle B is going to be our reference angle. Once we know where the reference angle is, right? Label your opposite, hypotenuse, and adjacent in that order. This has to be the opposite because it's across from big B. Again, why big B? Because that's what they asked us to calculate in the question. This has to be the hypotenuse, and that doesn't change, right? It's always across from the 90 degree angle. This leftover guy is my adjacent. Now I have to ask myself, what do I have? Well, I have the opposite, and I have the hypotenuse. What do I need? Here I need an angle. I need angle B. Which of the primary trigonometric ratios, again, I keep erasing it, SOHCAHTOA, which of the primary trigonometric ratios has opposite and hypotenuse in it? Sine. Okay, so the sine of, I don't have an angle, that's what I'm trying to find. So the sine of big B is equal to the opposite side, which I have labeled as 9.2, over the hypotenuse, which I have labeled as 11.3. Again, look at how important it is to label your triangle correctly, because then that will impact the flow of your entire answer. Now I can grab my calculator. I'm going to go 9.2, divided by 11.3. and take the sine inverse. And my answer is 54.50 degrees. Okay, it's time for the final example in this lesson, example number 4, and it says solve the triangle, okay? When you are asked to solve a triangle, that means they want all the missing sides and all the missing angles. So I like to make myself an answer box. Okay, I'd like to see this on assessments, solve the triangle. I don't know why I have that there, oopsie. And in here, I like to put all of the angles. Usually B comes after A, oh my God. And all of the sides. Now, before I progress, I'm gonna label everything on my diagram. Big angle A, big angle C, little c, big angle B, little b. Now, I like to, you guys know I'm crazy. This is driving me nuts. Okay, you guys, hold on. That's a little bit better. I like to put the stuff that was given to me in the question into my box. So B was 38. It's not labeled, but obviously C is 90, okay, because it's got the little right angle tick. Little c is 7.8, okay? Now, this is the stuff that was given, which means if I'm going to solve the triangle, I have to find big A and big B, or little b. And I like using this little solution box because then I don't forget anything, okay? So a lot of times kids might go ahead and find little a and big A and then forget that solving the triangle means find anything that's missing. Okay, to solve big A, I don't have to use any fancy new tricks. We know that the interior angles of a triangle add to 180. So to solve big A, I am just going to subtract what was given to me from 180, and big A ends up being 52 degrees. And I'm going to be honest, folks, you don't need to show me that work on an assessment, okay? So I'll add that to my answer box. Big A is 52 degrees. All right, good. Now all I have left is little a and little b. Okay, at this point, I'm going to go back to my diagram because I have to label my OHA. Even though I know A is 52, I'm not going to use that to label my OHA, because if I had accidentally calculated it incorrectly, now everything's going to be incorrect. I always think your safest bet is to use the angle they gave you as the reference angle. So if I make B my reference angle, that means this guy is going to be my opposite. This guy, of course, is my hypotenuse because it's across from the 90-degree angle. And this leftover guy is my adjacent. Okay, now I'm labeled, I am ready to go. I have to decide what it is that I have and what it is that I need. Well, I don't know if I'm gonna run out of room here. Okay. Can you see this? I have my hypotenuse, that's all. And I need, well, I need little a and little b, so I'm just gonna start with little a. Let's find that first. You could have found little b first, it wouldn't have made a difference. If I'm going to find little a first, a is the adjacent. So I have the hypotenuse, I need the adjacent, SOHCAHTOA. Which primary trigonometric ratio has adjacent and hypotenuse in it? Cosine. So the cosine of, what now? 38 degrees is equal to little a, my adjacent, over the hypotenuse, which if we go back to my diagram was 7.8. Now I'm going to solve using cross multiplication. Little a times 1 is little a. This gives me the cosine of, 38 degrees times 7.8. Again, don't calculate this and write it down. Calculate everything in one step so you don't compromise the accuracy of your answer. And little a ends up being 6.15 units. They didn't give me units in the question, so I'm not going to include them in length. Okay, now we have little a. I'm going to add that to my answer box. 6.15. The only thing I have left to find is little b. And here I have two options. Because this is a 90-degree triangle, and I know that this is 6.15, I could use Pythagorean theorem, okay? However, you guys already know Pythagorean theorem. I'm confident that you understand Pythagorean theorem. So I'm actually going to use SOHCAHTOA to find little b before we finish this question. So if I'm going to use SOHCAHTOA to find little b, that means, I wonder if I can sneak this in here. No, I'll go to the next board. Okay, so what do I have? I have the hypotenuse. It was given to me in the question. I need little b, and little b in my diagram is the opposite, right? Which, and I erased it again, which primary trigonometric ratio has the opposite and the hypotenuse in it? Sine. So the sine of, got to follow that up with an angle. In this case, my reference angle was 38. That's what I used to label my OHA. The sine of 38 is equal to the opposite side, which is little b, I don't know what it is, over the hypotenuse, which is 7.8. And guys, once you kind of become really comfortable, you don't need to show me that middle step anymore. B times 1 is b. Now, the sine of 38 times 7.8 is 4.80. Okay? Now, if you had the teacher copy of the note, you'll find that I did things a little bit differently. I found little b first using SOHCAHTOA, and then I found little a using Pythagorean theorem. Okay, and I got the exact same answers. So there are multiple ways to do these questions, which is always good news because then that means there are multiple ways to check your answer. Okay, so at this point, we are officially done learning how to use the primary trigonometric ratios. Your next lesson will be how to solve word problems involving the primary trigonometric ratios. But for now, just make sure that you're very comfortable. You are doing the assigned homework. You're messaging me with questions on Edsby, and just feel really excited about the fact that this is our last strand of the curriculum and our last unit.